Welcome to our topic radioactivity. This is a reaction that takes place in the nucleus. Initially we looked at chemical reaction that take place in the energy level due to loss or gain of electrons. My name is Samuel Nyamu. We refer to our previous lesson on the structure of the atom. We said the atom consists of two parts, the nucleus, which contains protons, neutrons, and the second part is the electrons, which orbit around the circle we call energy levels. All matter is made up of elements, that is, for example, carbon and hydrogen. The smallest part of an element is called an atom. Atoms of different elements contain different number of protons. The mass of an atom is almost entirely due to the number of protons and neutrons. If we consider an element, say X, the mass number is the superscript and the atomic number is the subscript. In this case, A represents the mass number, Z represents the atomic number. The mass number is same as the number of protons plus the number of neutrons in a given element, while the atomic number is same as the number of protons, which are also the same as the number of electrons in a given element. Therefore, A, which represents the mass number, is equivalent to the number of protons plus number of neutrons, while Z, which is the atomic number, is equivalent to the number of protons in a given element, while the number of neutrons is obtained by subtracting the number of protons from the mass number. In this case, A minus Z is equals to the number of neutrons. In general, the number of neutrons is equivalent to mass number minus the atomic number. Let us look at an example below. There are many types of uranium. We can look at the example of uranium-235 and uranium-238. We can determine the number of protons, the number of neutrons in the two uraniums. From the example, we said A represents the mass number. In this case, the first uranium has a mass number of 235 and the second uranium has a mass number of 238. Z, which represents the number of protons, is a subscript. For the first uranium, it has 92 and the second uranium, it has 92. So the number of protons in both uranium are the same. Both have 92 as the number of protons. To get or to determine the number of neutrons, we get the difference between the mass number and the number of protons. In the first uranium, 235 minus 92, we end up getting 143, which is the number of neutrons. In the second uranium, the difference between 238 and 92, we end up getting 146, which represents the number of neutrons. In this case, we can be able to see that the two uraniums has two different number of neutrons. This is referred to as isotope. In previous lesson, we said that isotopes of any particular element contain the same number of protons but different number of neutrons. Most of the isotopes which occur naturally are stable. A few naturally occurring isotopes and all of the man-made isotopes are unstable. Unstable isotope can become stable by releasing different types of particles. This process is called radioactive decay, and the elements which undergo this process are called radioisotopes or radionuclides. Radioactive decay results in the emission of either an alpha particle, a beta particle, or a gamma ray. The various characteristic properties of alpha, beta, and gamma radiation can be discussed as follows. An alpha particle consists of 2 protons and 2 neutrons. This makes them to become heavy and makes them to have a high ionizing power. A beta particle is or have a high speed, and this is because they are lighter in mass. It is produced when a neutron has decay in an electron and protons, and since they have high speed, they are moderately ionizing. Gamma rays have high frequency electromagnetic waves. They are produced when unstable nuclei loses energy. They are weakly ionizing, and this is because they have very high speed. The penetrating power of alpha, beta, and gamma radiation. Alpha particles are slow and can be stopped by a piece of paper, while beta particles can be able to penetrate a piece of paper and only be stopped by a strip of aluminium foil. While gamma radiations, since they have very high speed, they can penetrate a piece of paper, they penetrate an aluminium strip and only be stopped by a concrete made up of lead. Effects of magnetic field on the particles. The alpha particles are deflected towards the negative charge plates of magnet because they are positively charged, while the beta particles are deflected towards the positive charged plates of the magnet because they are negatively charged. Alpha and beta particles are deflected in opposite direction due to their opposite charges. Due to the much larger mass of alpha particles, they are deflected less as compared to beta particles. Gamma rays are not deflected at all because they do not have a charge. Alpha particle is identical to that of a helium nucleus. It consists of 2 protons and 2 neutrons. In general, it has a total of 4 as the mass number. A radioactive element will undergo decay by losing an alpha particle, which is equivalent to a helium particle, by mass number decreasing by 4 and the atomic number decreasing by 2. For example, an element X will decrease the mass number by 4 and an atomic number will be decreased by 2 to form a stable atom. For example, unstable radium with mass number 226 with atomic number 88 will lose an alpha particle by mass number decreasing by 4 to form 222 and atomic number decreasing by 2 to form 86, which is a stable random atom. The same random can lose an alpha particle to form polonium by decreasing the mass number from 222 to 218 and the atomic number from 86 to 84 to form a helium particle. What will be the mass number and atomic number of an element Y when thorium loses an alpha particle from 230 as a mass number and 90 as atomic number? Thorium will lose an alpha particle by decreasing 4 in the mass number to form 226 and decreasing atomic number by 2 to form 88, and the compound formed will be radium plus the alpha particle, which is equivalent to a helium, which has. You can practice by doing the question below Determine the mass number and the atomic number of polonium after it loses alpha particle to form lead. In our next lesson, we'll be looking at beta decay. Thank you.